Well, hello again. Now we're gonna move forward with what exactly blueprints are in Unreal Engine. And in this video, we're going to take a look at what blueprints are and how they use a concept known as inheritance, which is not difficult concept to understand, but it is important that you know what we mean when we say the word inheritance and what it means for game developers in general. And with that concept, you can be a much more powerful game developer in Unreal Engine. So, to understand the concept of inheritance, we first need to understand the concept of classes in game development. So, well, uh, when we say the word class, we are really meaning it to be a concept of classifying things into categories. And we can make an analogy by taking a look at things in real life and how they are classified into different categories. For example, we can look at the animal kingdom and we are not really going to use any scientific terms here. I don't really want this to be a science video. We are not going to use terms like, genus and species and things like that. I want you to understand that animals are particular category of thing. They are creatures and all animals share some characteristics. So, for example, all animals can reproduce, they can eat food, and they have some way of moving around. And we can say that all animals share these characteristics. So we can think of animals as type of category or a class of thing that contains these characteristics. Now, all animals may have these things in common. However, there may be different types of animals and that have their own unique characteristics. For example, there are mammals, reptiles, and birds, and these are all animals. So we can say that all mammals are animals, for example, but it doesn't go both ways. We can't say that all animals are mammals because some animals are reptiles, some are birds, and so on. So this is a one-way relationship. We can think of the animal category or animal class to be sort of like the parent class, and mammals would be a particular type of child class of the animal. So, because all animals can reproduce, eat food, move around, anything, that inherits from the animal class, such as mammals, reptiles, and birds, and they automatically inherit those characteristics. So, these characteristics, which are already under the animals, are inherited by these mammals, reptiles, and birds. They can do all those things. So we can safely say that all of these specific types of animals also reproduce, they also eat food, and they can also move around. So now let's move further and let's look into now each individual type of animals, mammals, reptiles, and birds, for example. While they do inherit some characteristics from the base parent class of animal, they also may have their own unique characteristics. For example, mammals have fur and they are warm blooded. Now, contrast with that with reptiles. They have scales and are cold blooded. So, just because mammals and reptiles are animals doesn't mean that they are the same in all respects. And birds, for example, are covered with feathers and they too are warm blooded. So, mammals and birds share the same feature of being warm blooded, but they still have other different differences in them. So now let's see and now let's take a look at the mammal type for an example. So we'll take just the mammal now. Now, just sorry for that. In the mammal type, Now we know mammals are type of animals, but there are in fact different types of mammals as well. And we can say that bears, deers, and squirrels are all mammals, but not all mammals are deers, for example. So this similar to the previous relationship of mammals to animals is a one-way relationship again. So even though all bears and deers and squirrels are mammals, not all mammals are deers, bears, and squirrels necessarily. Now, mammal inherits reproducing and eating as a standard characteristics for them within the animal class, and therefore bear, deers, and squirrels will also inherit those characteristics of the mammal. Mammals, however, are unique in the way that they have fur and they are warm blooded, but because bears and deer and squirrels are mammals, they too can inherit these traits. So, I hope you understand that from the animal class we came to mammal class, and from the mammal class, since we have all these features, all these characteristics of the mammals are automatically inherited by all the different types of mammals. So they have essentially inherited some features from the mammal class as well as the animal class. Now, in addition to inheriting these features, they also may have their own unique features. For example, so bears, for example, hibernate in winter, and they are big and scary, and deers also, they all are also mammals. They do not hibernate, the deers itself. They also have antlers, something that bears and squirrels don't have. So these are very, very specific features which are related to the antlers itself. And they are also not very scary, at least in the general, compared to bears and squirrels, of course, are different. And then bears and deers, and that they climb trees, and they are definitely not scary. So these are the features which are making each of the mammal different from each other within their own characteristics. So as we go down in this hierarchy of classes, we get more and more specific and have more and more specific traits and functionality that the previous parent class did not possess. Similarly now, so just like Animal Kingdom in Unreal Engine, we also have classes. And one of the more general class is the actor class. Now, the actor class has its own characteristics that all actors share. So you can take it that this is the parent class for your subclasses which are going to be coming in the future now, and these are the characteristics which the actor class has. For example, actors can be placed in the level. Actors can have a visual representation in the level. So some sort of, or maybe some sort of geometry, maybe a 3D asset or something like that. If you have an item in a level, maybe a rock, that item is an actor, and geometry that represents that rock is something that all actors are capable of having. Actors can be created and destroyed in the game. So they can dynamically be spawned and destroyed while the game is running. So this is the feature that all the actor possesses. Fine. Let's move forward now. Now, there are more specific types of actors. For example, there are pawns, there are static mesh actors, there are point line actors, and these are all the actors they inherit. So they all actors, so they inherit the functionality that all the actors have. But in addition, so if you see here, these are all the same as the parent actor class. So they all inherit the same functionalities. They can be placed in your level, they can be destroyed, and all those things. However, but in addition to this, each of these particular classes of pawn and static mesh actor and point light actor, they have their own unique characteristics. You can call it characteristics, or you can, in Unreal Engine, when you will start working on, you will see the something called properties, which you can change, for each of them, and it will reflect in that way. For example, pawn can be possessed And possession is something that a pawn can undergo, which allows us to be able to take user inputs such as keyboard strokes or mouse clicks, and that have an effect on the pawn. So if a mouse clicks, something will happen to the pawn, or if a keyboard is pressed, some key is pressed, something happened to the pawn itself. For example, we may want to move the pawn around by hitting the arrow keys on the keyboard. So that's something that pawns are capable of doing. So that's their own property, which might not be with the static mesh or emit lights, or with the light point director. Sorry for that. So going forward, now that is not something that a static mesh actor has the capability. It has a mesh information. I'll just go back, just pointing out, just to give you brief a bit more thing. So a static mesh, a static mesh information that has a geometry. So we will get into what mayors are and how to use them in the game. And this is a different than the point light. In point light actor, which has a capability of emitting light, shining light into the world. So while all of these inherit some features of the actor, they also have their own unique features as well. Now let's go and take the pawn class, just the pawn class, like the way we took the mammals as a class and try to be very specific in it. So let's take a look at the pawn specifically and see how the pawn can be a class that more specific type of classes can inherit from. So in Unreal Engine, we can have a character class and we can have a vehicle class. Now these are both pawns, character and vehicle. So in a sense, they inherit those features that pawn inherits. So they can be placed, a character can be placed, it can be visually represented by a character model itself, it can be created, it can be distorted, it can be possessed by the pawn itself. So in a sense, of course, they inherit the features of both the pawn and the parent class itself, but they can be possessed with which is a pawn specific feature. So let's move down further down. Let's look at the character. Now the character is a pawn and the pawn is an actor. Fine. So we can also say that a character is both a pawn and actor because it's an actor and inherits actor specific functionality, can be placed in a level, can have a geometry, and it can be destroyed in game. So all of the things which are basically the pawn characteristics, the actor characteristics, all combined together, they can be taken into consideration for the character when the character is actually added to your world itself in the game development. Now, and then of course, in addition to being a pawn, it also has a character specific functionality. These things are things that a character would need, but something like a static mesh or a point light, it would not necessarily need. So I'll give you an example. A character can be, a model, a 3D character of a human being, or let's say an animal, or anything, or a vehicle. It has all those statistics. It has all those characteristics like color, like textures, like other properties which will make it as actionable in terms of movement within the world. These characteristics are not there for, let's say, for a point light or for just a pawn itself. So this is a very specific characteristics of the character itself. And those are more specific details, but for now it's enough to understand that the character is a more specific type and that in it inherits features from both the actor class. So because the actor has its own functionality, we can create a new type of class and we can base it off the actor class. Fine. can be placed in a level, and we can have our own custom actor in this case. So we can create our own custom type of actor and inherit these features. In addition to giving our custom actor its unique functionality, for example, we may want some sort of explosive that will explode on the contact in the game, so we can easily create a new type of actor that has the ability to be placed in a level, how the visually geometry can be added to it, and be able to be created and destroyed. And we can also add features to it to make it, say, like explode, if that's what we want to be, to so we that understand the classes itself. So further moving forward, I hope you understand from the inheritance aspect, because this is very, very crucial to understand, because the whole Unreal Engine functionality build-up is all based on this particular concept of inheritance and classes itself. Furthermore, let's move to the next point. So, what exactly are blueprints? Well, a blueprint is a sort of what it sounds like, like if you think about a real life, what blueprints are actually are, they are diagrams or pieces of paper that show the plan to make a house or a building. So if you are trying to make a building, you first need the plan. And the blueprint provides a template or a way to give you the instructions for how to create a building in real life. Now blueprints have basically properties that they inherit from one of the Unreal Engine classes, which I have not actually mentioned here. I mean, furthermore, if we'll go to details of the engine classes, we can get into that. So we can have an actor of blueprint. So an actor can be of a blueprint type as well. We can have a pawn. We can have a pawn blueprint and so on, or so and so on. So, for example, we may have an actor blueprint now. An actor blueprint is not an actual actor. Fine. I mean, that is what we need to understand. So, an actor blueprint is might not be an actor itself, because why? Because it has the instructions capability of how to make things work, how to make things move around, and how to make things do certain things like instructions. Whereas all the things which I have already explained you before, like actors and pawns, and they don't individually have any instructions within them. It's the blueprint which is going to give them instruction what exactly to do. So, and this is just the same as saying blueprint in a real life is not an actual house. A blueprint is just a piece of paper. An actual house is made of wood, tile, plaster, carpet, things like that. So you need blueprint to create an actor. So let's go further. Okay. But we don't say that the actor, that blueprint is the actor to do it, to do that. We actually make an instance of the blueprint actor. So using blueprint, you can make multiple objects that are of type, that of the type of the blueprint, of course. So we may have an actor blueprint, and based on the actor blueprint, we can create an actual instance of actor classes. So you can have multiple instances of the blueprint itself. Each of the blueprint each of the blueprint can have different type of actors, and each of the blueprint might actually have different set of instructions for each of the actors which it has in it for the blueprint itself. And this actor is what we call as instances of the games. So in the game, we have actor instances, and we contrast this with the default, which is an actual blueprint. So the default blueprint has its own default properties that you can set on the blueprint, and we can basically drag actors into the world, create them on that blueprint, which is a sort of the template, or set the instructions used to create that actor. So that's how actor in blueprints are used in game. If you go to the next slide, I think the last one, I'll just going to What we are going to doing in is creating these blueprints, and these blueprints will be given some sort of properties and functionality that we want the actual actors in the game to inherit and emulate. So for example, if we want to create a particular type of actor, so place and then place it in the world, we are first going to create the blueprint itself. That's the first thing. And I will take you forward when we are going to actually create a blueprint and tell you exactly how this whole concept gets into effect in Unreal Engine. We are going to basically determine the blueprint, what's going to happen in the in game, and then we are going to create an actual actor based on that blueprint and drag it and place it in the game, possibly make copies of it and so on. So that will be multiple instances of the same blueprint having same instructions and having all the things which are will be used throughout your whole game, and it will act as also in the same way. So this concludes classes and blueprints, and we are going to solidify this knowledge with some examples as we create our games in Unreal Engine. Well, hello and welcome back. Today we're gonna start on our work in terms of the stuff which we have learned before, which is about actors and blueprints. And before going into the details, this is a project template for a rolling game which we will be actually building after we are over with the understanding of how actors and blueprints are created in Unreal Engine. This template will be provided as a project file which will be given to you, so you can actually do all the testing and all the understanding of actors on this particular level itself. So let's get started. Now, in Unreal Engine, everything which you see here in your viewport and in your world is actually known as actor. So as we discussed, an actor can be a static mesh, which you see most of them are actually static meshes. Static meshes are those which cannot be deformed, which cannot be changing their shape. They can change their colors, their properties, but they cannot be deformed, they cannot be destroyed, and all those things. So if you see and you select on one of them, you will see that on the right side you will see whatever has been selected, and it's going static mesh actor. So Unreal Engine understand everything in the form of actors, and these actors are by default which are already coming along with it. With Unreal Engine you can easily add it from shapes. If you bring a cube from the selected menu, you will see static mesh actor cube. That's how it is added. I'll just remove it. So now we want to create our own characters and our own actors actually in this case. How do we do that? Let's make a folder with the name of do we have a blueprints here? No, I don't think so. Okay, so let's under the content folder go up and select new folder and call it blueprints. Yep. So under the blueprints now you can click. You can see there are a lot of options here after right mouse click. Earlier we could actually create the folder, and we see there are a lot of other advanced assets which we can create once you will be going into details on terms of creating high fidelity games, high animated games. This is where you will be also requiring certain areas to work on. However, for our purpose of for this tutorials actually, we're gonna make our first blueprint class. So let's click on first blueprint class itself. Once you will have clicked actually, what you can see here all the parent classes will be shown. So if you see here, actor, pawn, character, player controller, game mode, action component, all these scene component, these are parent classes, and each of these parent class have its own properties. You can see the details on the side right side of it for each of it. For actor, an actor is an object that can be placed in the spawn, as I already explained you before. However, if you want to have more details, you can click on open documentation, which will take you to the Unreal Engine website directly on explaining well actually. Okay, let's try. I think this is Unreal Engine 5 documentation. It has to be updated. But once you are here, you will be able to find out different information about the actors and all those things for explanation purposes. However, for now, we are going to create a very simple actor. So let's click actor. And once you click the actor itself, it will ask you to create a name for it. As a best practice, always name your blueprints with prefix BP for blueprint and give it a name. So let's say in our case it's like my new actor. There you go. So now we have a my new actor already added to it, to our assets. Let me just make the speed a little faster for the camera. Okay, now like any other asset which you can place in your viewport, you can also pick your particular blueprint and bring it in your world. And once you will bring it in your world, you will see on the right side in the world outliner that it says my BP my new actor is placed and is part of your overall collection of the assets which you have used in your viewport in your world itself. However, if you see here, of course you can move up and down as any regular actor itself. All these assets can be also move up and down, you know, all those things can happen. And you can of course increase the size of it, but as of now, since this blueprint has nothing visual assigned to it, so you cannot see anything which is can be shown and can actually be seen actually by the user itself. So let's go to the content drawer again and double click our blueprint. Okay, so let me just make it a little bit smaller in terms of the screen space. Okay. Okay. So this screen is basically all the details which are related to the blueprint itself. Let me also dock it on the side itself so we can easily swap between the screens. So what you see here as of now, there is an icon in the middle. This is the center point, the origin basically for your blueprint from a visual aspect. So anything which will be placed here actually will be in the center of it. On the left side, if you look at it, we have a panel where we can actually add components which can be then visually represented with our blueprint here. On the right side, every actor or every element which you will be adding, in our case once we will add another actor, actually we will have the details in terms of its properties. On the left side, I will not go into details as of now, but I will come back to it when we will go to relevant particular topic itself. So to give the visual understanding of that how our actor should look like, at the very basic we can click add, and if you click add you will see there are a lot of stuff which is available in terms of assets, in terms of actors which Unreal Engine has already built in, and you can place them and pick them and add it. Actually, for our case we can select the static mesh, or we can type static mesh in this case. Once you click on static mesh, you will see that it has been added under your actor hierarchy and it has its own properties here. The default scene root, definitely after this one we will come to in details at what exactly this means and how does it actually overall reflect in terms of your blueprint. For now, let's just click the static mesh and let's give our blueprint a visual aspect. If you see on the right side, there is a property called static mesh, and under static mesh this allows you to select any kind of static mesh, or by the way static mesh is nothing more than actually 3D asset It can be a chair, it can be car, it can be not character, of course. It can be what you call cube, like whatever you want to add up. Actually, it will be added here. So in our case, we want to add, let's say, in our case, let's try to cone. Okay, there you go. So once the cone has been selected, this is the static mesh which is already given, available to us in Unreal Engine by default. As of now, it doesn't have any material allowed assigned to it. So let's do one thing. Let's give it a material before we can actually jump into more details. So let's go and see what materials do we have. Okay, the blinking carpet. Unreal Engine default light. No, this is not what we want. Let's go to the content starter content folder where we have already our some of the materials available. Select the material, go to the material folder, and let's select just the basic wall. So just click on this one. You can either scroll down and drag the material like this, or you can just select it and then press the arrow sign here and it will assign the material to it. So now we have a visual representation of our blueprint which has an actor in it. So let's see, do we see here? Yes, we do see here. Actually, sometimes what happens if you have multiple actors added to your blueprint, it might not show all the other updates in the real time. For that purpose, it is definitely required that you click the compile button here so that it compiles the blueprint. However, if you click on the compile, let's see. Okay, and under the compile, you will see a compiler result. Now, the compiler result means all that coding, all these information which you are adding up to your viewport or your functions. At the back end, the compiler, it will generate a code which is understandable for Unreal Engine in order to execute your blueprint in the world which you have already creating. So in a simple term, anything which you have created as a function, to make it workable, to make it interactable in your world exactly, you need to compile it first. Sometimes you might get errors, you might get warnings, and those have to be, of course, corrected before you can actually run your blueprint in your world itself. So our case, since it's a very basic actor, which is a static actor itself, we can save it and we can see now that we have an actor solely created by ourselves, which is of a type blueprint, and we can place it in our world. Now you can do more than that. So let's go, where did we actually created our actor? Let's go to the blueprint folders. And now here you have a blueprint which is basically holding this mesh in it. You can create multiple instances of this particular blueprint. So you can add, and it will keep on adding on your right side in the world outliner as much as you want. Now there is a other thing which you can do. Now if you see your blueprint and you have multiple blueprints, each instance here is actually a same blueprint. However, you can change the properties for the mesh which is added to it under each for certain purpose, like you want to change the color. So what we can do, let's click on this particular blueprint and double click the asset. Once you will double click the asset, if you go on the right side, let me just give you a little bit more space in terms of understanding. So once you will click on this instance of your asset, of your blueprint actually, you will see that you have selected the instance 3 of your blueprint. It has a default scene root which is already in this particular thing. It's the same format. It is actually showing the same, and it's showing the static mesh has been selected for your blueprint. So now from here, if you want to go back into the static mesh and if you go to the properties of it, and if you see the element here for the material, just let's go and just pick one of them. Let's say I'm just gonna make it easy. uh, let's say let's pick this one. Okay, go back to this with the scene, and there you go. Although you see that it's the same blueprint, but you can play around with the properties for different instances of your blueprint itself, for the two static meshes itself. So if we just play our game here, and we'll try to see if it runs here, you will see here that we have our instances and everything is added to it in this case. I'm just closing out. So this actually shows that how we can create a very simple actor, and once the simple actor is created, there are more to it, and this is just a starting point for it. But we will cover the next part, which we will be explaining on what is the default scene root for this particular area. So now what we're gonna do actually is we're gonna discuss on what is actually a root component. So let's go back and have a look into our blueprint which we created. Now this is under the content folder. This is the one which we created. Let's open it. Okay, so let's go with the viewport again and see what we have at the left side. So if you see at the left side, we have our BP my new actor, and we see there is a default scene root, and under the default scene root is actually a static mesh. Now we can create multiple types of static meshes and we can attach to the scene root. If you want to see the scene root, actually what you can do is click on the static mesh and just move any side of it, and this one in the middle is actually your scene root. That's the origin. If you click on the scene root, and if you see on the side panel, on the right panel, you can see that you can't actually really move it, or you can't actually change the direction of it, or you can't move it in any other direction, because that's the root, that's the origin. Everything which you add to this particular actor is going to be around this particular origin itself. So now in this case we have a static mesh which is relatively moved to the root component, which is the scene root component. And if you compile and actually look into your viewport, you can see that okay, there's I think this is gonna confuse you. Let me just delete few of them. Yeah. Okay, so you can see now that your static mesh, which is actually a part of the blueprint actor, is away from its root component, which is the scene root component. This is exactly where it's showing. So now if you can click on the blueprint and you move around the blueprint actor, you can see that you are actually moving the root component and not actually the static mesh. Static mesh goes along with it. Why? Because it is actually attached to the default scene root. Now I want to actually add up a very important aspect in terms of attaching the components. Now you see that our current static mesh is actually attached to the scene root. In the same way, we can have endless static meshes here or other components which can be attached to the scene root as well. So let's say that we want to have another element, like another asset of a static mesh type, to be added to our viewport. Let's just click on this once, or you can even go right click and rename, and for simplicity purpose we call it cone. Now let's add another component, and let's say of static mesh again, and this time we call it cube. And for this purpose we'll go to the cube and we'll go to the static mesh properties of the cube itself, and we will go and select and add a cube to our particular actor. There you go. Okay, so the default material is still not white. Actually Let me just select this one and go back here, select this one, and then assign it. So there you go. So if you see at this side, on the left side, we have a default scene root. Cone is actually attached to the default scene root, and the cube is actually attached to the cone. So what we can say that cone is actually a child of the default scene root. Cube is actually a child of the cone. So that's the parent for the cube, and the cube itself is a child of the cone itself. However, if you see when we placed it into our viewport, we can see the cube is actually basically at the same location where the scene root is. Let's compile and just see how it looks in our world. So here you go. I'll just move over a little bit. So you see here, now since we are moving it up, you feel like that you are actually moving the cube, whereas it's not the case. You are actually moving the scene root. Why? Because the cube is exactly placed on the scene root itself. So to have clarity on this one, let's move the cube on the side to have a clear understanding of what's going on. So this is our scene root. We have one object which is of cone attached to the scene root, and then we have cube attached to the cone itself. We can move around the cube as it is like this, okay, and maybe the cone also. But before going with that one, let me just go back and show you what exactly happening. Now you see that if you select the origin of our actor, blueprint actor, we can move around and the cube and the cone will move along with it. Okay, so let's go back. However, if you don't want the cube to be the child of the cone, just left mouse click, bring it upon the cone itself, and this will actually detach the cone from the cube or the cube from the cone itself. So now the default scene root is actually the root of both. So if we go back here and we select this one and we move around, you see that both are moving. However, if we go back again and we want to place this up, so in the viewport of your blueprint actor, let me just increase the speed here. Blueprint actor, you can move your objects where you want to place them in the blueprint, compile, and you will see now that the cone in relevant to the cube is on a different location and different height, and the cone and the cube is on a different height itself. Let's go back and then do a little bit more of understanding of what's going on here exactly. So now if we want to add up the cube again to the cone, so you can just left mouse click and bring over the cone itself. This will attach back to it. Okay, once attached to it, actually, if within the viewport you move the cone, you will see that the cube is moving along with it. Why? Because cube is now child to it. However, cube itself, since it's a child, it can move around wherever you want and there will be no issue at all. If on the cone you select again, and let's say we want to increase the size of the cone, so if we go back and select the middle icon and we just drag our mouse, you can see that you can even increase and decrease the size of both at the same time. That's how the parent child concept works in Unreal Engine. So this is how attachments are there. Now another point which we want to include here exactly, which is about the default scene root. Since we don't have any visual representation of our origin of the default scene root, we can however go and select our cone, left mouse click, drag it over the default scene root and leave it there. Now you see that we don't have any default scene root available anywhere. And why exactly what's happening? Because now the cone has become the default. That's the origin of your actor itself. And the cube remains the child of it. So no default root. The default root is now the cone itself. You can bring up the cube, and if you want to move the cone, of course you won't be able to. Why? Because it's a default scene root. If you go back into your world and you see that this is where your now the new default scene root has become, because the cone is now the center of origin, and that's how it is. Now if you want to, let's say, rotate the cone itself, you will see that the cube is rotating around it. Why? Because that's the origin, that's where the whole thing is actually changing. And in this way you are able to create your actor by adding up the elements, and also making a very important understanding that how a default scene root can be changed into an actual mesh, and how attachments can work. Having said that, we will now move on to our next topic, where we will get into more details on this one. But I hope you are catching up in terms of understanding, and I'll catch you later. So let's get into more details now. If we go to our BP actor, blueprint actor, we have made our cone and cube as a parent-child relation for this one. What we can do now actually is that we'll get into, let's just try to remove, well, just leave it actually. I mean, why not? I mean, let's just get a little bit more of a look and feel for the purpose of itself. So here we have, and let's just move it around, move it a little bit here, and just place it in this case. So let's go back. Now I will introduce to you for something which is called event graph. If you see on the left side at the bottom, you will see a my blueprint, which is basically our blueprint which we have created. And you can see that under graph we have something called event graph, and under the event graph we have some types of events. Now event graph is an area within the blueprint where you actually start building the logic of your game, and the logic within this particular blueprint which you are creating. One of the thing, I will go to the construction script in the later stage, that will be also covered during the tutorial itself. But let's say go to the event graph, and when you go to the event graph, you will see by default these events are already added to your graph itself. You can click them and just move around them wherever you find it's movable. This will be used when you will start building quite complex kind of blueprints where you have multiple functionalities. So maybe you would like to give a space. If you use the wheel actually and move up and down, you can zoom in and zoom out just for your own purpose itself. And this is where we're going to start. So an event begin play is one of the event which can be triggered when the game starts. So as soon as your game starts, this is the particular event which is going to be triggered, and whatever you're going to connect to this particular event is going to be executed. Let me just unpin it. If I can just remove it, or just leave it like that. Okay, that's good. So in this event begin play, you can see that there is an arrow, and this arrow is basically showing a message called exec. So exec is basically used for executable. So anything which is connected through this particular area is going to be executed as a function. So if you left mouse click and drag a wire out of it, just like this, you will see that there are a lot of executable functions which are available, which can be executed based on if they are going to connect to the event begin play. So for the simplicity purpose, we will use a very simple function, something called print string. So if you see here, print string will be showing. By the way, the F which showing here is actually telling us that this is an actual function which can be used to be executed. So let's say print string. Now Once you have connected the both nodes, so what happens that when the event begin play will start, this particular function will be triggered and it will be executed. Now the print string function, it does only one thing. It just prints a message which is actually here. If you see here, you can see hello, and this is what's gonna actually print a message on the screen when you will start the game, and when the game will start, you will see actually on your screen. Let's compile. Once compile is there, go back to your viewport and press play. If you see at the left, you will see hello. It stays for a very short time, because it has only a little bit time in this case. And if I play it again, you will see that okay, there is hello being printed. So that's the function which print string is being used for. By the way, print string is also a debugging function which we can use and we will be using throughout our tutorials in order to identify if something is working properly or not properly. Fine. So that is something which we're gonna work on as we move on with these particular tutorials. So let's say that we have executed this particular print function. Once the game starts, we can, let's say, put another string to it and say, well, hello world. So now our function will actually print the hello world message on your screen. So let's just compile and play, and there you go. You see hello world at the top. Hello world is traditionally is being used as a as some kind of an achievement as a programmer, where you actually see that okay, this is the first time I worked on a programming building logic, and this is how it works. So yeah, we use hello world a lot in this case. So congratulations that you have already reached that milestone where you can see the hello world being printed on your screen. Now what's happening here exactly, that these blueprints are basically codes, but we cannot see those codes actually because Unreal Engine has provided us a way of using blueprints to hide those coding functionalities and make it easy for us to just to connect the nodes itself. Now if we move forward now, and what we can do actually, let's click on this one of it and we can copy and paste it. So Control C and Control V. So you can see that we have another node which is created of print string, and it has the same message. You can now change the message and let's say what's up. Fine. And in the same way, you can connect the execution of this particular node with this one, or alternatively, you can also do the same thing by dragging the pin from here and bringing it back into the print string. So other way around, or the same way, actually, it will be connecting to each other. And now what will happen actually, when the event begin play will trigger at the start of the game, it will actually print two strings. So let's check it. Let's play. Hello world and what's up. If you have noticed now that hello world is coming afterwards and what's up is coming before, well, that's how the whole functionality is working, because all of these particular nodes are being executed in a sequence. So that's the first sequence, that's the second, that's the third. So once what's happening is when the hello world is being printed, it actually pushes down, and then the next set of instruction comes and what's up, which is the next print string, and that actually gets printed at the top, and this is how it shows up. Now another thing I want to actually show you that if you don't want this particular print string to actually trigger, you can just press on your keyboard Alt and left mouse click, and this will disconnect the particular node from edge. However, one of the things which you really need to see and internalize is that once you will bring the pin out of one of the node and try to connect to the other one, you will see this check mark, which is actually showing that this is a valid connection, that if you will connect it, this print string will actually get executed. However, let's say you move it to the in string. So this is showing that this is not actually a valid connection. It is not of the same nature, and so it will not even allow you to connect. See, it doesn't allow it. So once you will have this particular check mark, it means you are doing a valid connection itself, and it will execute as per how the instructions are being given to Unreal Engine. So let's do this one. Now, if we just open and press these small arrows at the bottom of these nodes, you will see that you have further more properties of the print string node. In this case, if you see that if we compile here again and just play, that both of the strings stays for few seconds and then they disappear. However, if you want to increase the duration for both of them, you can increase it by going to the duration part, and let's say from 2 seconds we want to change it to 10 seconds for both of them. Let's say good enough. Compile, save, go back and click play. Now you see that both of the strings are being displayed on your screen at the left corner for at least 10 seconds, and then they disappear. There you go. You can do another thing. Under the properties, you can, maybe you want to print one of the string in a different color and the other one in another color. You can go back and on a color picker, and let's say we have it like a red, and this one, I don't know, maybe green, maybe something of this nature. So both of these strings will be printed for 10 seconds stay in 2 different colors. Compile and let's play. There you go. So you have hello world and you have WhatsApp, and both are in different colors, and both of the duration are of 10 seconds, and then they disappear. So that is the concept of how event begin play will work. And we will be using the print string a lot in our tutorials as we move forward. And in that case, what will be happening is that we will also get to know that how at different stages we are able to debug by just using these simple functions and get it done. If you, however, try to disconnect this particular string from the event begin play and compile and then just play, nothing will happen, because at the event begin play we disconnected our all instructions what to be followed by Unreal Engine, and this is how the whole thing has been done. So furthermore, we will get into more events as we move forward, and then we will be getting into how to use these events in our game, and also how to prepare our gameplay based on all those particular events which we are going to cover in these tutorials.